Hi guys, how are you? I hope you are doing well. So today we're gonna continue with chapter 8. We're gonna estimate the population mean mu when the population standard deviation sigma is unknown. Okay, so remember in section 8.1 we estimated the population mean mu when sigma is known. Okay, but today sigma is unknown, and in this case we're gonna use a sample standard deviation S. So we're gonna use, of course, a sample mean X. So we have a sample of size, let's say N, with a sample mean X bar and sample standard deviation S. So we're gonna use the sample standard deviation S to estimate actually the population mu, population mean mu. Yes. Okay. So let me just remind you in section 8.1. Okay. So we estimated the population mean mu when sigma is known, and we said the margin error E was equal to the critical value Z alpha, right, times the standard deviation, the population standard deviation sigma over square root of n, right? Then we said then confidence interval is given by, x bar minus e, x bar plus e. Confidence interval is given by, x bar minus e, x bar plus e, right? Now, so in this section, 8.2, we don't know, sigma is unknown, right? Sigma is unknown. So we cannot use this formula here. So, but we have a sample of size n. So we have a sample of size n. Okay, and with sample mean x bar. Okay, and sample standard deviation S. Okay, then in this case, confidence interval is the same formula. We're gonna have x bar minus e, x bar plus e, but of course the formula of the margin error is gonna be different. So this e here is gonna be different. So then a confidence interval. So today the confidence interval, so let's call it then a confidence interval is given by, again, x bar minus e, x bar plus e, where the e, so the e is going to be equal, to the critical value of student's t distribution times s, the sample standard deviation over square root of n. Okay, so s, this is the sample standard deviation. Okay, of course the n, that's the size of the sample. Okay, but this so t sub C or T index C, that's a critical value of, and I'm going to explain how to find the critical value of the student's T distribution. Okay. So here, let me just remark, so we are using a different distribution than the standard normal distribution. Remember here in 8.1, when the sigma is known, we have this critical value Z alpha. So to find Z alpha, remember, we had to use, we use the standard normal distribution. But here, when sigma is unknown, okay, and so we use the sample standard deviation S, but so this TC, it's not given by the normal distribution or the standard normal distribution, but it's given by this student's T distribution, okay. So now, how do you find this TC? So how do we find this critical value T sub C? Okay, well, we can use the table 4. So please check the table 4. It's on it's posted in CUNY Blackboard. The students T distribution. Okay. So let's say you have, so let's say you want to find this critical value for, let's say, 90% confidence interval. Confidence interval. Okay, and we are using a sample, let's say, of size, let's say n equal to 9. Okay, so we have a sample of size n. Okay, so if you check the table number 4, so you can see here, you can just ignore the first two rows, and then you have like here. You have here C, okay, and there's this df here, okay. So df means the degree of freedom, and it's actually equal to n minus 1. So df, so this df here, this is the degree of freedom, and it's equal to n minus 1. So df, let me write it here. So df, that's the degree of freedom, and so degree of freedom, and it's equal to n minus 1. Okay, so this is, so df, this is n minus 1 here. So this is, there's C here, that's the confidence interval. So for example here, I want to find the critical value for 90% confidence interval. So my C would be equal to 90% or 0.9. So this is my C. So C is equal to 90%. Okay, because I want to find 90% confidence interval, then C is 90%, or if you want, this is 0.9. Okay, so what would be df here? N is equal to 9. So my degree of freedom, df, so df would be equal to 9 minus 1. So that's equal to 8. So my degree of freedom is 8. So if you check the table, so just ignore, the first two rows with the one tail area and two tail area, okay? And then you have CDF. So C, the values of C goes like, so it starts from 0.5, then you have 0.75, then you have 0.8, 0.85, then 0.9, 0.95, I think, then 0.98, then 0.99, and 0.999. Okay, now degree of freedom, so we have here 1, 2, 3, etc. And somewhere here, let's say you have 8. Okay, so my confidence interval, so we are looking for 90% confidence interval, so it means that the C here, so my C is 0.9, that's 90% confidence interval. Now, the degree of freedom, again, that's n minus 1. We said it's the size of the sample, which is 9 minus 1, so it's 8. So my degree of freedom is equal to 8 here. So this is my degree of freedom. So it's n minus 1. So the critical value TC would be equal to, so here you have 0.9, here degree of freedom 9 minus 1, it's 8. So my TC, or my critical value, would be 1.86. Okay. So here, so for a 90% confidence interval with a sample of size 9, the critical value T sub C is equal to 1.86. So here's the answer. So for 90% confidence interval, okay, with the sample of size n equal to 9, of size 9, the critical value T sub C is equal to 1.86. Okay, so then, the margin error E, again, it would be equal to, this critical value T sub C times S over the square root of n. S, that's the sample standard deviation. Okay, so let's do a numerical example. So let's see how it works. So here's an example. And of course, you can find more examples in the lecture notes. Let's say the adult lions gave the following weights in pounds. So the following weights. Let's say using pounds as unit, so in pounds. So let's say you have a first lion, the weight of the first lion is 68 pounds, second lion is 104 pounds, then 128 pounds. The fourth lion, the weight of the fourth lion is 122. Let's say then 60, and then 64, okay. So let's say the question is to find 75% confidence interval of the population. Confidence interval. So this is just a sample. This is a sample of size 6 because here we have 6 lions, right? But, so the question is to find the confidence interval for the whole population of lions. So for the interval, confidence interval for the population. So for the population mean mu. Okay. So again, this is just a sample of size 6. This is just 6 lions. But I'm looking for a confidence interval for the mean of the whole population, for the whole population, not just this 6 lions here. Okay, so you see here, guys, the thing is here. So here, the standard deviation of the population is unknown, right? The standard deviation of population standard deviation sigma is unknown. So here, the population standard deviation sigma is unknown. sigma is unknown, right? We don't know what's this population standard deviation sigma, right? So what we can do here, we have this size, this is a sample of size 6, right? You have the sample, we can compute the mean, the sample mean. So what will be the sample mean? So we can compute the sample mean, x bar, so that will be, 68 plus 104 plus 128 plus the 122 plus the 60 plus the 64 over, so how many lines? We have 6 lines, so that's over 6. So then x bar actually is going to be equal to 91 pounds. Okay. Now, what will be the sample standard deviation? Sample standard deviation S. So let's compute the sample standard deviation S. So S squared, remember, for a sample of size n, the standard deviation. So S squared first, that will be a sum, x minus x bar square over n minus 1. So it's like, so this is like, S squared would be like, so my first x is 68, so it's like 68 minus 91, then square, plus 104 minus 91 square, plus 128 minus 91 square, plus 122 minus 91 square, plus 160 minus 91 square, and then plus 64 minus 91 square, and then the whole thing divided by, so we need to divide n minus 1, so 6 minus 1, so it's divided by 5, so, okay, and then, so that will be S squared, and then S, the sample standard deviation S, that will be square root of S squared, and actually that will be equal to 30.7 pounds. Okay. Now we want to find 75. So we're gonna use the sample standard deviation to estimate the the population mean mu. So we're gonna find 75% confidence interval for the population mean mu. Confidence interval for mu, right? So 75%. So we need to use, we need to find the critical value T sub C using the table number 4. Okay, so C here, that's 75%. So that's 0.75, right? That's C. And degree of freedom, df, degree of freedom, that's n minus 1. N is the size of the sample. So we have 6 lions, so that's 6 minus 1. So that's 5. So the degree of freedom is 5, right? So then we check our table here. So here's the C, here's my df. So C, you have 0.5, and then you have 0.75, then you have 0.8, then you have 0.85, etc. And then df, you have 1, 2, and then you have a 5 here, okay? So my my confidence interval is 75%, so this is my C, so it's 75% or 0.75. My degree of freedom, we said it's the size of the sample, which is 6 minus 1, so it's 5. So here's 5 here. So what will be the critical value TC? So here, that will be equal to actually 1.301. So this is 1.301, okay? So the critical value T index C, so T index C is equal to 1.301. we are not done yet. So that's my critical value. So now I can find the margin, the margin error. So E, again, it's this critical value, the TC, times S, the standard deviation of the sample, over square root of N. Okay, so the critical value T sub C is equal to 1.301, right, times S. So my S, my standard deviation S is equal, so my standard deviation we said is 30.7. So here it's times 30.7 over square root of N. N is the size of the sample. We have 6 lions, so it's the square root of 6. And so then E, so this is actually equal, so margin error E is equal to 16.31. Okay, so the answer, so the 75 confidence interval, so 75% confidence interval for the population mean mu is, so it's supposed to be X bar minus E, X bar plus E. So what's X bar? X bar, that's the sample mean, right? So here's X bar. So X bar, we said the sample mean is 91 pounds, right? So that's X bar, so it's 91. So it's 91 minus the E, the margin error, so that's 16.31. And then 91 plus 16.31. So that's the confidence interval, 75% confidence interval. So that would be equal to, so my confidence interval would be 74.69 and 107.31. Okay, so that's my confidence interval. So what does it mean, this answer here? What does it mean, this interval? So we are 75% certain that the population mean, the lions, the average, the population average, the average of the weight. So we are 75% certain that the average weight of the population, the average or the mean, the average weight of the population of the lions, so the average weight of the lions, of the whole population of lions, not just the sample, okay, the whole population of lions, the average weight of the whole population of lions is in the interval 74.69 107.31. Okay, so again, we are 75% certain that the average weight of the whole population of lions, not just the sample, but the whole population, the average weight would be in the interval 74.69 107.31. Okay, guys, you can find more examples, similar examples in the lecture notes, and I guess I'm gonna stop here, and I will see you